This is Algebra 2, Unit 3, Lesson 6 on piecewise linear functions. Now, what we're going to be looking at is some piecewise linear functions. We did some of these back in Algebra 1, and these are a little more complicated one. All right, a piecewise linear function has different equations for different portions of their domains. So they are made up of line segments that have different equations when you're working with the values. So let's take a look at this piecewise linear function given by this formula. We have f of x equals x minus 3 and f of x equals 1/2 x plus 4. When we use these functions depends on the domain that is given. This is the domain over here. So for the first equation, we use this when x is greater than or equal to -3 and less than 0. So if I'm looking at my values of x here, my first equation would be used starting at -3, and I would use it until I get to 0. Now, would I actually use it for 0? No, because it's not included. So from here to here, I would use x minus 3. So if I wanted to fill in my values, this would be -3 minus 3 would be -6, -2 minus 3 is -5, -1 minus 3 is -4. Now, when I get to 0, that switches to the other function, 1/2 x plus 4, when x is greater than or equal to 0 and less than or equal to 4. So from 0 to 4, I would use this function. So half of 0, half x plus 4, this would be 1/2 of 0 plus 4 would be 4. Half of 1 plus 4 would be 4.5. Half of 2 is 1 plus 4 is 5. Half of 3 is 1.5 plus 4 is 5.5. And half of 4 is 2 plus 4 is 6. So if I want to look at what this function looks like, -3, -6 would be here, -2, -5, -1, -4. Now, when I get to 0, it switches to the other function, but what if I'm like at 0.5? Well, this would actually go up until I get to actually 0. So if I figured out the 0 value for this function, it would be at -3, would be right to here. But that's when it switches. But if I'm right here, it's got to go up to right here. So because it has to go right to here, I would do an open circle there because it doesn't actually equal that value, but any value before it does. So right up to 0. So this part of the function would be right up to there with an open circle at the end. Because once I get to 0, I actually jump to the other function. So it would be 0, 4, 1, 2, 3, 4. And then 1 would be at 4.5, which would be there. 2 would be at 5. And then 5.5. And then at 6. And then there's the rest of my function, and it would be up like this. So it's got a jump in it at x equals 0 when it jumps to the other value. All right, now let's look at the range for this. The range is the y values that work. So I actually have two split ranges because my ranges start down here and end up here. But there is nothing between -3 and 4, or 5, 1, 2, 3, 4, and -3 and 4. All right, so your range actually has two parts. It's all the y values, so the range, remember, is the y's. This group right here, your range would be from -6 until you get to 3, but notice 3 is not included right there. Now, if you did this interval notation, this said interval notation, sorry, it would be -6, comma, 3, parenthesis. Okay, and, or in union with, that's what this means, in union with, we have the other part over here. So this y starts at 4, and it goes until you get to 6. So in interval notation, that would be bracket 4, comma, 6. So this is set builder notation, this is interval notation. So you can see this actually has two different ranges. All right, now at this level we should also be able to be given a piecewise function and figure out its equation. So let's take a look at our function that we have right here on the graph. We actually have three pieces here. So we have three functions. F of x is going to have three different values. So I make my big bracket here. Let's look at our domain intervals that we have. All right, so looking at our first domain interval, if we look at our domains, all right, left to right, my changes start here, and then it changes there, and ends over here. So these four yellow lines would be my domain intervals. So my first line is between what two x values? Well, my x value is between 1, 2, 3, 4, 5, 6, 7, 8, negative 8, and it goes until I get to negative 2. That would be my first domain value. My next domain value would go from negative 2 until I get to 3. Now, since I use negative 2 for this one tells me that actually at this they will have the same point at this one. So one of these has to be equal to, and one of them is going to be not equal to. So we know which one to which. It doesn't really matter. All right, so this one goes from negative 2, and then that gets to 1, 2, 3. And then the third domain is from x equals 3, and since I have equal to here, I'll make not equal to there. And that gives me in 3 until I get to 1, 2, 3, 4, 5, 6, inclusive. So those are my three domain intervals. All right, so what we need to do now is figure out the equation of each of the lines. All right, so let's look at the horizontal line. First of all, probably is the easiest one. All right, this is a horizontal line. What's the equation of a horizontal line? It's going to be y equals. So 1, 2, 3, 4. This is going to be f of x is equal to 4 between negative 2 and 3. All right, now the other two, we have to figure out the equation of the line. All right, so what do we need for the equation of the line? All right, so my first section here, from here to here, all right, we know it should be y equals mx plus b because it's a line. So what is your m? All right, well, I can pick any 2 points and then count. Well, my m, I would go from here, 1, 2, 3 over 2. So my slope on this, 1, 2, 3 over 2, 1, 2, 3 over 2. M is going to be 3 over 2. All right, now my b is my y-intercept. Now, since this graph, actually, I could extend this pretty easily. 1, 2, 3 over 2. My y-intercept, if I were to extend this graph, let me do it as a dotted line so you can see what I'm doing. If I were to extend this up to here, the line, it will cross the y-axis at this point, which would be 1, 2, 3, 4, 5, 6, 7. So b is going to be 7. So my first section, my equation, is going to be y equals 3/2 x plus 7 between negative 8 and negative 2. All right, now we can do the same thing with the other graph, the third line over here. We knew this one was 4. All right, now between 3 and 6 is the other graph that we have. So we want to check out our slope. Now notice here, going left to right, this slope is going to be negative. So the slope is going to be negative. It's down 2 over 1. M is going to be negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. All right, now what's my b value going to be? Well, again, if we want to go backwards, we would have to go up 2, back 1. So up 2, back 1, up 2, back 1, and we'd have to keep going for this one. So our b isn't as easy because it goes off the graph. However, we can use the point slope formula. Y minus y1 equals m times x minus x1. All we need is another point. So we know m is negative 2. That would go here. And I'm going to pick this point right here. And that's the point 1, 2, 3, 1, 2, 3, 4. So I'm going to plug in the point 3, 4 for my x1, y1. So x1, I'm going to use the 0.34. It will be y minus 4 equals m times x minus 3. Y minus 4 equals negative 2x plus 6. And then move the 4 over. Y is equal to negative 2x plus 10. So the equation of this line, if I were to continue this up, would be y equals negative 2x plus 10. So there is my piecewise function. I can see that I've got it on here. Now in the next class, I will show you how you can do this on the calculator so that you can check your answers as you go. All right, let's try one more. Let's look at some of the parts of the piecewise function. Now, consider the piecewise linear function g of x equals 5 minus x when x is less than 2, and g of x equals 1/2 x plus 2 when x is greater than or equal to 2. So, determine the y-intercept of this function algebraically. Okay, so algebraically, how do you know where the y-intercept is? The y-intercept is where x is 0 and then you have y. So we need to know which value is going to be, or which function we're going to use for this one. Well, if x has to be 0, we would have to use the first one. So g of 0 would be 5 minus 0, which is equal 5. Now, why can the function have only one y-intercept? Because for every input, there can only be one output for it to be a function. So you can't have an x equals 0 and have a different y. There is only one output. So if x equals 0, y is going to be 5. All right. Now, let's find the x-intercepts of each individual linear equation. All right, the x-intercepts is where you have a value of x and your y is 0. Whoops, your y is going to be 0. So, if on the individual equation, we would have 5 minus x is equal to 0, and the other equation would be 1/2 x plus 2 is equal to 0. So if I solve this for x, I subtract the 5, and I end up with negative x is equal to negative 5, and divide by negative 1, x is equal to 5. And 1/2 x plus 2, I subtract the 2, and then multiply by 2 on both sides, and I get x is equal to negative 4. So there are my x-intercepts algebraically. All right, now let's go ahead and graph this function. Remember that 5 minus x is really negative x plus 5. So the y-intercept is going to be 5, and your slope is going to be negative 1. So 1, 2, 3, 4, 5. And then your slope is going to be negative 1. And this is only going to be for x is less than 2. So down 1 over 1, and then down 1 over 1, but when I get to here, it's going to be a circle. So if I go backwards here, up 1, back 1, up 1, back 1, I can go right back until I get to the value. So when I do this half of the graph, whoops, let me do it in solid point here, solid line coming down, it looks like this. And then the other graph is 1/2 x plus 2. All right, so plus 2 would be here. But we only want to start this where x is greater than or equal to 2. So that would actually start right here. So this point starts up 1 over 2. That's going to start there. Notice I didn't put the y-intercept on. I just used it to count. And then up 1 over 2, up 1 over 2, up 1 over 2, and then draw your line in. All right, so the function looks like this. All right, so why does your graph contradict the answers you found in Part B? Well, look at this. This has a y-intercept of 5, but it has no x-intercepts. It doesn't cross the x-axis. So how can you resolve the fact that the algebra seems to contradict your graphical evidence of x-intercepts? Let's talk about that tomorrow in class. And I will also, again, show you how to use the graphing calculator, and we will look at the last problem, exercise 4, as well.